Everybody, I want to spend a little bit of time going over some types of reactions. We're going to talk about double replacement reactions in this video, but before we get started, I want to make sure that we go over some definitions here and some other things. And so we want to talk about products and reactants. Okay, in a chemical reaction, the reactants are usually on the left-hand side. Okay, these are the reactants, and what is made in the reaction are called products. Okay, and so this is what we start with in a chemical reaction. Like, these are the things that we mix together at the beginning, and these are the things that we end with. Okay. The thing to keep in mind, I said that the reactants are primarily on the left, and then by default, then the products have to be primarily on the right. The thing to keep in mind, and I'm not trying to trick you, but you may see reactions written this way, backwards, that the blunt side of the arrow, the end of the arrow, goes towards the reactants, and the arrow always points at what's being made, the products. Okay. The second thing before we start talking about double replacement reactions that I wanted to mention is the diatomic elements. Okay, the diatomic elements are Honkelbrief. Okay, that's H-O-N-C-L-B-R-I-N-F, and these are how these elements are found in nature. If we have hydrogen gas, H, it's not found in nature as H, but rather H2. If we have oxygen, you may remember from biology, oxygen is O2. Okay, it's not O. And so we need to know this because when we write reactions out, we may have to write oxygen gas or bromine liquid, and that's Br2. So I remember this by saying Honkelbrief. But to get to the the reaction, these are double replacement reactions, and a double replacement reaction will start with two compounds, and typically we have to worry about solubility rules, or whether things dissolve or not. And while that's not for this video, I think that it's important to keep those in mind for later on. Okay, now the way that I always remember double replacement reactions is like the wife swap. Okay, there's this silly TV show, I don't even know if it's on anymore, where two couples switch wives, not with an L, but with a W. And so you start off here, and then all of a sudden the wife will go back to, to a different person, and then this wife will go here, and so it's like wife swap. Okay, ignoring all the social implications of reality TV shows, that's just my easy way of remembering it. Okay, so here what we end up having is we have potassium bromide, okay, and silver nitrate, and what happens is they swap partners. And so now we have potassium nitrate, the K has gone here, and then the silver bromide, the silver has attached to the bromine. And so this is called a double replacement reaction because now two things have switched places. And so this is the type of reaction that is most prevalent in this level of chemistry. You're going to see a lot of double replacement reactions just about anywhere you go. Okay, so it's two compounds forming usually two other compounds, and you have to worry about the solubility rules. Okay, so that's double replacement reactions. Have a great day.